Hi, welcome back to MOG Economics YouTube channel. Um, in this lesson, we're looking at the concepts of factorials. In our build up, to permutation and combinations, you must have heard about factorials before, and so it's not hard like, at all. Let's dive right into it. So factorials actually refers to factorials is used to like determine the number of arrangements that a set of things could be put into, right? So and so under it we now begin to talk about permutation. So the kind of arrangement, kind of possible arrangement um, of events, right, that care about the order in which the events are stated. However, for combination, it's also deals with arrangement of events, like possible number of events, like how many events can you get from this particular thing. So in how many ways can this particular thing be arranged? But for combination, it does not care about order. So, but when we do examples, you're going to really understand what I'm trying to say. Now, you must have seen something like this on your calculator, like an exclamation mark, right? You're like, okay, it's not English. What's exclamation mark doing on your calculator? So let's say you have something that is like three exclamation mark. This 3 factorial, that's what it means. And to be honest, this is what it just means. 3 multiplied by the numbers before it times 2 times 1, which is then going to be equal to 6. That's all. So we have 5 factorials. So it's 5 multiplied by all the numbers before is 5 times 4 times 3 times 2 times 1. So 5 times 4 is 20, times 3 is 60, times 2 is 120. Like that's just the thing about factorial. So generally speaking, how do you express factorials? So if you have n factorial, this is equal to n, right, multiplied by n minus 1, minus 2, n minus 3, on and on like that, n minus 4, then factorial. So if the number doesn't end there, then continue n minus 5, blah blah blah. So like that's just how it goes. Just be subtracting 1 from the previous numbers, then you continue like that. Now there are some other set of examples. Let's say you have let's say like you have let's say part 2. Let me call this part 2. So let me call this part 1. Let's say you have 5 factorials. 5 factorials divided by 3 factorials. What's going to be the answer? So 5 factorial is 5 times 4 times 3 times 2 times 1, right? Divided by 3 times 2 times 1. So all of these parts will cancel out all of this part, and then you're left with 20. That's the answer. However, you could also have done like this: 5 times 4 times 3 factorial. See what you have underneath is 3 factorials. This cancels this, it saves you space and time, and this guy equals 20. So it's as simple as that. Okay, so any other thing, so let's say this is 1, this is 1. Then for 2, you have something like 7 factorial multiplied by 5 factorial. 1 factorial multiplied by 5 factorial divided by 3 factorials multiplied by 4 factorials. Okay, so let's go. I can just do, so like I did 7, I just stopped 7 times 6 times, because 4 on its own is 4 times 3 times 1. So if I leave it as 4 factorial, it's still okay. So the reason why I'm leaving it as 4 factorial is because I want this to cancel this, right? So I can still keep on expressing this guy, 7 times 6 times 5, then times 5 factorial. Now divided by 3 factorial is just 3 times 2 times 1. So this cancels 6, because that is 6. So I have 35 times 5 factorial. 5 factorial is what? 120. So 35 multiplied by 120. So what's that? 35 times 10 is 350. 350 plus 70, that's 420. That's like 4,200. Is that even the answer here? Alright, so that's 4,200. So if you like, you do it this way. If you like, you don't do it this way. Like that's just the thing about factorials. Is there? I think I have other things. Factorials with the same letters. So now let's talk about this. Like this factorial with numbers. I have a different set. Oh, no problem though. So let's just keep enjoying ourselves. So a different section. We call it like section B. Oh no, no need for section. Just parts. Another part. Part 3. I just want us to like do as many as possible. So you have something like find the number of ways in which all five letters in the word greet can be arranged. Find the number of ways in which all five letters in the word greet can be arranged. But before we even get to that, let's talk about something. In how many ways can the letters A, B, C be arranged? So in how many ways can the letters A, B, C be arranged? A, B, C be arranged. So here we are already doing permutation. It's permutation because it's using all the letters, right? So A, B, C. I want to link this up with what do you call it? With permutations like it's factorials because there's a formula for it. So if you look at it, there is A into BC. This is one arrangement. There is A into CB, like this is another arrangement. Then I'm done with picking A, so I can pick B. There is B into AC. This is one arrangement. There is B into CA. This is another arrangement. So I'm done with B. B has picked the whole thing. So there's C into bracket AB. This is an arrangement. Then there is C into bracket BA. This BA. This is another arrangement. Okay, so I said this is permutation, but like let's use it to talk about permutation and combination. So in this case, right? How many do we have? 1, 2, 3, 4, 5, 6. So our answer is 6. So 6 ways. We can arrange the letters A, B, C in 6 ways. What we've done here is permutation. Why are we calling it permutation? Permutation because order is important. Say like is B coming before C? So here B is coming before C. It's different from C coming before B. That's what I mean by order being important. Do you understand? So me standing in front of you is different from me standing in front of you, different from you standing in front of me, right? So when those things matter, you're talking about permutation. So in this case, you have 6 permutations, right? But how many combinations do you have? As long as you have all the letters, right? So like the same letters, so you are just turning them up and down, like just rearranging them. Right. So this is going to have just one combination. Right? Why? Because it's just the 3 letters A, B, C. You're just like interchanging them. So for what do you call it? For combination, this does not matter. Right, so you have 6 ways. So you are going to have 6 permutation and 1 combination. So that's all. 1 combination. So now let's now assume that we have like long letters, like this one is easy, ABC. You can just do 6 ways. What if you have a lot? Because if you have hippopotamus, so how many ways can you arrange hippopotamus? So let's use this ABC to now understand how to use a formula to get the number of ways that something can be arranged. Now look at the word ABC, right? Now the what do you call it? The for you to pick the first letter, right? So you can choose between either picking A first, or B first, or C first. So you have the choice of picking 3. You have 3 choices. Like you can pick 3. You can pick A, B, or C. To pick the first letter, you have 3 choices, right? A, B, or C. Now we call that 3. So you are going to like because you have 3 choices. You want to use a formula to get this. So you say 3 choices to pick the first letter. But once you've picked the letter, let's say you've already picked B. So how many choices do you have in picking the second letter? Right, so you have just 2 choices. You can pick between A or C. So just 2 choices. You say multiply by 2. Let's say you picked A. So what's the final choice? So to pick the last, you have to pick C. There's only one choice to pick the last letter because C is just the one there. So 3 times 2, we say that one is times 1, and then this is 6. What is this literally? This is 3 factorial. So you see how it works. So we look at ABC again. Look at ABC. Once you want to pick one letter, you want to pick like the first letter. So how many choices do you have? You have 3 choices. You can pick A, B, or C. So your choice of picking the first letter is 3. So you say 3, then multiply by you pick 1. How many letters do you have left? 2. And you want to pick one of them between 2 choices. So you have 2 choices. You want to pick one of them. So 2 choices times 2. Once you pick the second one, you only have 1 letter left. So that's just one choice. 3 times 2 times 1. So that gives you 6. So yeah, 6 factorial. 3 factorials. So what we just literally do in factorial is that instead of now arranging these things one by one, when we have something like this A, B, C, this doesn't have to make sense. So like our combination doesn't have to make sense. right? Could have ZYX, ZYSQ. Like it doesn't have to be a meaningful word, but how many times can in how many ways can you arrange it? So if I have ZYQR, so that's going to be 4 factorials like that. So because I have 4 letters, it's just 4 factorials. So I'll be having 4 times, 3 times. Do you get it? Like so that's just like the idea behind the whole thing. So let's now begin to look at more examples. Look at this following questions. So in how many ways can the following words be arranged? You have grades. So solution. Now for grades, how do we approach this kind of problem? G is different from R. These are 5 different letters. So A, the answer is just 5 factorials. 1, 2, 3, 4, 5. That's all. Right? B, so we don't need to be picking one after the other again since we already established the relationship that exists between everything. Now for grades, right? We can say 5 factorials for grades. 1, 2, 3, 4. Why? Because E and E, you have 2 letters. So E and E is like looking like 1 letter. So do you get what I'm trying to say? So when you have a letter that is occurring more than once, there's a different way that we approach it. So what do we do? Well, the whole letters, you have 5 letters, so you say 5 factorials, but you say divided by how many times you have E? So 2 times divided by 2 factorials. So this is literally 5 times 4 times 3 times 2 factorials over 2 factorials. This takes this, and then our answer is 60 ways, right? 5 factorial is 120 ways. So you can see like it's divided. The answer was like the answer is divided by 2, like compared to 5 factorial. Why? Because you have 2 letters that's you have a letter that is occurring twice, right? So it's not going to give you the same number of ways because E is E. So if you are picking E, right? So let's say you want to form a word. One of the word will be EGRET. Following one, so it's still like it still start with E, like E is E. So it's not going to be the same as when you have different letters entirely. Now for C, mathematical. So what's the first thing to do? Count everything. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 letters, mathematical. Um, so 12 factorials, 12 factorials. Then divided by some words appear more than once. M is appearing, you have 2 M's, so 2 factorials, right? How about A? A is here, A is here, A is here. So 3 factorials. You see the way it's going. Then is there any other? So T is here, T is here, right? So you have 2 factorials again. So do you have similar T, H, just one H, E is just one E. We picked M, right? We picked A, we picked T, I is just one I, C just one C. I think that's all. So how do we solve this problem? 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 factorials. So I will just stop there over 2 factorials, 3 factorials, and 2 factorials. 3 factorials carry 3, that's 3. Now 2 factorial, this and this, they are just 4. Like 2 times 1, 2 times 1, so it cancels 4. So I'm left with 12 times 11 times 10, 9, 8, 7, 6, whatever, equal to, this is a large figure. What is this? Okay, I need to go write the final answer. I didn't write the final answer. So I just left it as 12 times 11 times 9 times, what else? 12 times 11 times 10 times 9 times 8 times. Okay, you can just figure out the last figure, and then so that's going to like solve the issue. Okay, number of arrangements. So well, bottom line is that for this kind of thing, so number of arrangements is going to be the um, general rule would then be that n factorial divided by, so those different ones that you have, p factorial, q factorial, r factorial. If you have other sets of letters that are repeating themselves, s factorial, etc, etc, like that. And so this is like the general rule. So the denominator is representing letters that are occurring, more than once, right? So yeah, that's that. What other example do we have? So I think we still have to talk about two different things. Is it two? Um, or maybe two different things or thereabouts before we then bounce and leave this class. So everything we're doing here is permutation, right? there is permutation. Yeah, everything we're doing is still permutation, because it doesn't matter whether one is, it does matter if one letter is coming from another letter, one number is coming from another number, etc. So let's look at this. This is a different partial example, other examples. So in this particular instance, simplify n minus 1 factorial, n minus 1 factorial divided by n factorial, right? So then the other one, this is A, and the other one is B. So we have a n plus 3 factorial, n plus 3 factorial divided by n plus 1 factorial. So is there anything else? Okay. Um, what else? Okay, no problem. So we have this. So how do we address this particular issue? No problem. For the first one, for A, we are going to be having n minus 1 factorial. Then this one that is under, it is n into brackets n minus 1 factorial. You know the rule now. So if we didn't want this, you can say n minus 2 factorial, etc like that, right? But it's okay. You can just stop at n minus 1 factorial because we want the two of them to cancel out, and then we are going to be having 1 over n. So the n minus 1 factorial, it cancels its neighbor, and all of its family people. Now for B, okay, if we look at which one can we change? If you are removing 1 from this, we might get something similar to this guy. So this is n plus 3, n plus 2. It keeps reducing. So n plus 3 minus 1. Do you understand? So n plus 1 factorial, because there's n plus 1 denominator here. So like there's no need to continue. Divided by n plus 1 factorial. So these two guys can leave themselves. So n plus 3 into brackets n plus 2. When you multiply this out, n squared plus 5n plus 6. So you get a function. That's how to address that particular one. So the last part that we should talk about. So yeah, what if you have questions like this? We've done the one for grace before that, but there's something that I want us to see from it. You have, in how many ways can the word great be arranged if A and E stand next to each other? So in all of the arrangements, so there could be an arrangement like this: A, G, R, E, T. So in this case now, A and E are not standing together, but we are saying that if A and E must stand together no matter the arrangement, right? So in how many ways can the whole thing be done? Now, so we have that's number one. That means we must have G, R, E, A like this, T. T all the time. So anytime you see E, you see A next to it. Um, things like that. E, A, T. Now if there's a different arrangement, let's say E, A. Let me even say A, E this time. A, E, at least they're standing next to each other anyways. A, E, G, R, T standing next to each other. So how do we approach a problem like this? Now the thing is that then that means EA first is seen as one letter, like one event, because they must always be together. So like it's seen as just one event. Now since EA must sit together, right? So that means the whole thing has been reduced. The way to solve this, just has been reduced to first letter, second letter, third letter, EA together, and third letter, then T fourth letter. So what is that? So we have four. What do you call it? 4 letters. That's 4 factorial. But is that the end? No. Why is that not the end? That's not the end simply because EA on their own is like 2 factorials. Like you can have E. You understand what I mean? So in how many ways can you arrange EA? It's 2 factorials now. So it could be EA, it could be AE. So this is one possible what do you call arrangement. This is another possible arrangement. So like 2 possible arrangements, which is 2 factorial. Do you understand? So EA itself can be arranged 2 possible times. So you may be saying EA on and on. So for a set of combinations, EA. Now for a different set of combinations, AE. Do you understand? So that's why you must also factor in this particular one. So if there were 3 letters that must stand together, then that means that after let's say it was EAT, the EAT would be like 1 letter, then RG, that would be 3 factorials, then multiplied by In how many ways would you be able to arrange EAT on its own? And that would be another 3 factorials. So that would be 3 factorials multiplied by 3 factorials. Do you understand? Is it? No? Yeah, that's right. But here, because EA can be arranged on its own, like in two different places, so 2 factorials for that, so multiplied by 2 factorials. So what do we have? 4 factorial is going to be, so the whole thing is 4 times 3 times 2 times 1 times 2. You feel me? All right, times 1. Yeah, 2 times 1. This. So 4 times 3 is 12, 24, 48. So the whole thing is going to give you 48 ways. That's how to approach a problem like this. So first, you look at those two letters. It may be two people sitting next to each other. So the question says these two people must sit next to each other. So you see them as one person at first. So you get a number of factorials in the usual way. They multiply by how many people are sitting together. Is it two? So it will not be letters. So we look at issues like that in subsequent lessons. Now, in the 60-meter hurdle, there are 5 runners, one from Austria, Nigeria, Ghana, Belgium, and Singapore, different countries. So, how many different finishing orders are there? How many different, like in how many different ways can these people finish? So, Nigeria may come first sometimes, and then you have Ghana following it. Nigeria may come first in some situations, Belgium runner will be following it. So, you understand what I'm trying to say? So, at the end of the day, for number 2I, 2 is the I, 2I, you'll be having 5 factorials, 5 possible combinations is equal to 120 different, what do you call it now? What is this? Finishing order. 120 finishing orders, and then that settles that. All right, so all these things are still talking about permutation, to be honest. Although we've not spoken about the formula for permutation, really, but like it's still talking about permutation. Now, what is the probability that the finishing order that Grace, obviously one of our students, predict we follow the exact order of first, second, third, fourth, and fifth at the end of the game, like by the end of the game? So let's say Grace is sitting and Grace says, Nigeria is going to come first, right? Because she's a Nigerian. So Grace picks Nigeria first. Then she picks Belgium next. Then she likes her African countries. She picks Ghana next. Singapore next. And then I think Austria and Austria. So this is our prediction, right? So something like this. So what is the chance, what's the probability that what she has predicted, right, will come true? This is just one possible combination out of 5 factorials. This is just one possible arrangement actually, out of like 120 different ways. Do you understand? So if she's lucky and this happens, a chance of this happening is equal to 1. Like this is just one possible arrangement out of 5 factorials. So like 1 divided by 120. I said that it's not difficult, right? So common sense, in incorporating our understanding of what do you call it, probability into this again. Do you understand? So yeah, we're going to end the class here. Then we're going to look at a few assignments before we now begin to talk about permutation and combination properly and more elaborately in future lessons. Ladies and gentlemen, so we have these assignments. Number 1, in how many ways can the word ejagbigbe be arranged? Dry fish, ejagbigbe, right? This hyphen, right, is not a word, please. So it's as if you have all the letters together. So in how many ways can the word ejagbigbe be arranged? Good. Now number 2, simplify n minus 1 factorial divided by n minus 2 factorial. We did something like that. And number 3, how many arrangements of the word achieve are there if A, there are no restrictions on the order of letters? So no restrictions, it could be anything, any way it wants to be arranged, like just normal permutation. And but don't forget that some letters may be appearing more than one, some maybe a letter or more. So just always consider that. Now B, if the first letter must be a V, if the first letter must be a V. Now what does that mean? And let me give you an example of how to like solve that. So if you have Suya, for example, then the first letter must be a Y. You understand? So it simply means you already have Y, you already picked Y, right? So the rest, SUA, is what you are rearranging. Do you understand? So Y is already there, Y is already out. So it's like 1 multiplied by then 3 factorial. So your answer is going to be 3 factorial. You feel me? So that's the way. So because you already picked V, so V is no longer part of your arrangement. You understand? V is out, then whatever all these ones as are rearranging them, just adding V in front of this stuff, V in front of it. So you are rearranging the ordered letters besides V. Do you understand? So that's the way you kind of figure that out. Now see if letters A and I are together, we've done something like that. And then D, what am I doing? So D, if letters A and I are apart. Now how do you solve that? First do generally, right? The word achieve, what is the possible permutation of the word achieve? So you get that. Then I've thought you have to find the permutation for when the letters are together, right? So the first one, the general permutation, whether where that doesn't care where letters are arranged, whatever you get there, minus the permutation that cares that A and I are together. So whatever it now gets, when you do that, is the answer to D. Do you understand? So generally, so it's more or less like A minus C. Whatever I get in A minus whatever I get in C. That's how I solve it. And E, what is the probability that a word chosen at random will not be in the form of achieve, right? It's going to be a different set of combinations. So A might not begin it, might not be. So what will that be? We should know how to figure that out now. We did something similar in during the lesson, so you can figure that out. So thank you. See you when I see you again.